I was talking, I forgot to unmute. Howdy, welcome on in, everyone. All right, so we've got our ads done, pre-rolled. We've got our game made. We're following our tutorial in Godot. We've actually managed to set up all the stuff so that we documented our tutorial process. If you look in the YouTube description on our channel, a link to this specific site is going to be shown so that you can go through and do this kind of demo on your own. They give you all the assets that you're going to need. And we're going to kind of move on from here and move into finishing it up, adding some extra stuff, and see how much troublesome it is. So then we can at least say we've got a finished project. So we've done everything like adding enemies, added a scoreboard, a little bit of a GUI, and we're moving on to get these extras done now. All the stuff that actually makes it good. So, welcome on in. I hope you're having fun. Let me know if the music's too loud or anything. I can lower it just a hair. Or if I need to be louder, that kind of thing. So, let's just get into it. Feel free to expand the gameplay with your own ideas. The default gray background is not very appealing, so let's change its color. One way to do this is to use a color rect node. Make it the first node under main, so that it will be drawn behind the other nodes. Alright, so main. We're going to go up here and we're going to add a child. Make it the first node. How do I make it the first node, though? You don't tell me anything about that. Control up. So, okay, I can do that. So is this like an order of operations then? It's going to start at the top. It functions like by checking for the start game first stuff, then it goes down? Okay, cool, sure. Alright, so we've got that. Color rect only has one property, color, so choose the color you like and select layout, anchor presets, full rect. Inspector color rect. Jeez, you are bright. Let's change these so we actually have some colors to pick from. I feel like a light blue. So we did the color rect and select layout, anchors, presets, full rect. Or at the top viewport or in the inspector so that it covers the screen. Oh, I did this in the inspector. I'm not sure where the other ways of that were. So choose a color you like and select layout. Is there another layout button I missed somewhere? I don't see it. You could also add a background image if you have one. So by using a textured rect node instead. So let's try that. So let's say we disable that. So texture rec. Load. We've got some random images we can load in here, right? Oh, they're not in this directory though. All right, so let's try it just to see what that does. Yeah, we'll use League of Legends. That might be a little small.
Auto insurance all seems the same until it's time to use it. With USAA, it's easy to
Still another one too small.
repairs and access roadside assistance right through your app.
We
Or
could probably
you
make
could
that
take
work.
your chances somewhere else. Get a quote today.
Sure, we'll do that one. Rename. Texture 1. We need to copy that into our Godot directory. Oh, I just realized I renamed that very poorly. Oh well, I don't think that's gonna matter. So then we should be able to go in here, do a load from our art. We have access to this. Size. Keep centered. Yeah, and I think that's it. We also need to move this up there. Keep that visible. And then we'll try this. Oh, my picture's too small. Okay, so instead of keep size, let's do bit width proportional, stretch mode, scale. It's still not working. All right. Keep centered, maybe? It doesn't seem like that's changing anything. Do I need to do this first? We'll try 5 instead. Yeah, no, still not changing anything. Okay, maybe we need to take a bigger picture. But I feel like we should be able to modify it from there, right? Because it's not tiling, it's not doing any of that. We don't need to add any scripts to it. Actually, before we do anything, let's turn that back on. It's blue. Okay. So we've got the color correct. Why is the texture not showing up there then? So whichever one is on top goes further in the background. Okay. So when we did the texture rec, or the color rectifier, we changed the anchor presets. So what if we go here, anchor presets, full rect. Maybe that's what I was trying to need. I wouldn't have thought that it was going to be that, but this is why I don't know anything about what I'm doing, though. So test, and hey, it stretched it. Okay. Cool. So we have a background. It's a shitty background because it can't see anything. Oh, hey, look at this. Let's try the transform. Oh, how big was it? 480. Were you able to adjust it just like that? Uh-oh. You can. So I could just make it like this if I wanted to. Just place it like that. A bit more manually. You know what? Let's try this real quick. See if we can make the entire game play within her ear. Close enough. Yeah, this looks absolutely terrible, but... Alright, we found another way to resize it. Alright, so we have added a textured background. So now we have sound effects. Sound and music can be the most effective way to add appeal to the game experience. In your game's art folder, you have two sound files. House in a Forest loop for background music, and GameOver.wave for when the player loses. Add two audio stream player nodes as children of main. Okay. So audio stream player. We could create children nodes by clicking on the plus sign here. And one of them music, and the other death sound. Hey, thanks, Unlink. So far, today's going pretty well. Now that I've had a day to kind of let the knowledge sit in from yesterday, I'm improving. Trying to understand the UI has been the biggest trouble so far, because, well, that's pretty much all we've done. But we're making progress. We're getting more familiar with the UI. That's why we're just kind of going through the tutorials. We're not making our own code or using our own assets or anything like that. So we're just building on getting more familiar with our tools and what they can do before we work on specializing into each tool so that we can understand and create more unique situations for what we want to do. All right, so I am going to move on and let's see. Audio is automatically imported with the loop setting disabled. If you want the music to loop seamless... Oh, no, I missed one. On each one, click the stream property, select load, and choose the corresponding sound effect. Over here. In the inspector nodule.
We make wallets happy.
Load. Whoa, no. Music. Shut up. There we go. Back to our regular soundtrack. Alright, so we're going to attach our House in the Forest loop to that. All audio is automatically imported with the loop setting disabled. If you want the music to loop seamlessly, click on the stream file arrow, select Make Unique. Then click on the stream file and select the loop box. What? Where's the loop box? So we did the Make Unique. Click on the stream file. Oh, is okay, so they've got it like right under here. Beat counts, bar beats. So mine doesn't have that. I don't need to move that. I've got a little bit older one, or the tutorial's a little bit older. Audio stream player. Theirs is listed as 2D. Did I click the wrong one earlier? Add 2 audio stream players. I did, okay. Delete music, delete death sound, because I made it 2D. So audio stream player. Name of music. And death sound. So then we should go to music, stream, load, House in the Forest. Parameters, looping. Okay. So it's a little different, but it should be set to loop on. I mean, it looks a little different, but I think that's still the same thing we're moving there. Okay, there. That's fixed. So then we go to the death sound. Oh no, the music, we didn't select Make Unique. Alright, so then we'll go over here to our death sound. Not yet. Looks like we'll get to that. Alright, so to play music, add music.play in the new game function and music stop in the game over function. So music.play in the new game function. Where is our new game function? Is that in main script? Might help if I actually spell it right. New game. Yes, it is. Alright, so we've got music play there. Music stop in game over.
With QuickBooks Solopreneur, keep your finances organized year-round. Move from books to taxes.
This is a lot of ads today. Alright, so finally, add deathsound.play in the game over function. So then we need to actually add the death sound in here. And we need to make sure that it's not looping because we only want it to play once. So in the game over, it should say music stop, death sound play, music stop, function new game, music play. Yeah, we've got that, I believe. Since the game is played with keyboard controls, it should be convenient if we could also start the game by pressing a key on the keyboard. We can do this with the shortcut property of the button node. Okay. I guess that makes sense. In a previous lesson, we created 4 input actions to move the character. We will create a similar input action to map to the start button. So select Project, Project Settings, and then click on the Input Map tab. Project, Project Settings, Input Map. In the same way you created the movement input actions, create a new input action called Start Game, and add a key mapping for the Enter button. So add new action, Start Game. Listening for input. There. Now, I want to check. Can I do this and map a second button to it? Oh, that probably won't work because we need to set up a separate function for it. Okay. So right now we can only map one button to it. Oh, did I save it? Now would be a good time to add controller support if you have one available. Attach or repair your controller. Actually, I do have a controller. Oh, where is it? Haha! We've got a PlayStation 1 already set up. Enter physical. Attach or repair your controller, and then under each input action that you wish to add controller support for, click the plus button and press the corresponding button, D-pad, or stick direction that you want to map to the respective input action. Oh, is that how you do it? So, start game. I can do the plus, listening for inputs. Joypad, yes! Okay, cool. So, then we can add multiple ones to the start button. So, move down, Move left. Move up. And move right. And let's also do the joystick. Move up. Oh no, sorry, that's move right. Move up. Move left. Move down. So we've got joypad axis 1, 0. These look like the same thing. Joystick left, joystick right, joystick up, joystick down. Okay. Cool. Okay, controller support was much easier than I thought it would be. That is awesome. All right, I want to test this.
We made USAA for homeowners who like being ready.
Okay, that didn't work.
That's why we have safety tips for things like fire,
Save scene.
home security, and USAA insurance just in case. USAA
Okay, so I didn't map my start button, but I can use joystick. I can use my keypad, and my sound effects are working.
Did I feel any pressure playing
Cool.
Shadow? The answer is yes. We're some kind of recording of Sonic 2, the end credits, and you'd hear people.
Enough ads. I need to go find a longer video that has no ads. All right. So, in the HUD scene, select the Start button and find its shortcut property in the inspector. Create a new shortcut resource by clicking within the box. So we have the... Where was it? In the HUD scene. So Start button and find its shortcut property in the inspector. Create a new shortcut resource by clicking within the box. Open the events array and add a new array element to it by clicking on array input event size 0. So I have to select shortcut first. Array input event size 0. Size 1. This one is quite a bit different. So create a new shortcut resource by clicking within the box. Okay. Open the events array and add a new array element to it by clicking array input event. And add element. So 0 action. New input event action. And name it start game. Is that right? Create a new input event action and name it start game. Pressed on, start game. Strength, event index -1, device 0. Now when the start button appears, you can either click it or press enter. So that's all we were needing? I guess it was. Alright. So we added sound effects to it. Cool. Save scene. Actually, save all scenes. I was expecting that to be a little bit longer, honestly. I didn't think we would get through all of the flavor text stuff of the game in a matter of seconds. There's still so much to learn, but you can take a moment to appreciate what you've achieved. Sharing the finished game with others. If you want people to try out your game without having to install Godot, you'll need to export the project for each operating system you want the game to be playable on. See exporting projects for new instructions. After exporting the project, compress the exported executable and PKayge file, not the raw project files, to a zip file, then upload the zip file to a file sharing website. Alright, so this talks a little bit about what I had the issue with. Both Audio Stream Player and Audio Stream Player 2D still exist in Godot 4. Audio Stream Player should be used for music background, as it's non-positional, while Audio Stream Player 2D should be used for positional audio, most sound effects. Okay. How can I add touchscreen input to this game if I export it to Android? And then in process, you can add this. Okay, so we have to make audio unique in order to enable the loop checkbox, it seems.
Here you go, miss.
I am! No, check this out. We actually got sound effects and a background color. We added music, we can move around, and when we die, so we're good. And actually, that was the end of this project. I was expecting this project to take a bit more time. But welcome on in, Snow. Hope you're having fun at work. So we've finished this up. Like, there's nothing else to do as far as like following the tutorial. I'm still not super familiar with a lot of the tools and elements of this. We're gonna close that though. And I want to take a bigger look at some of the code because there was a few things in here that I definitely didn't understand, and I want to take a closer look at, see if I can piece it together. So we're gonna start by going through our HUD. So, like this base section of code, I don't understand. Like, what is the function process in Godot, and why is one like a function ready? Because there's like no end messages, which is what I'm used to with object-oriented programming, the little bit of experience I have. So I was expecting all my code to have to go between these, and this would like kill it after it's done, but that wasn't the case. It worked just down here. So like, let's go check this out. We're gonna go to Google. You know what? Let's use our good buddy ChatGPT. Okay, so in Godot Engine, the function process is a built-in callback function that is called once per frame while the node is active and in the scene tree. Here's what each part means. This is the function in Godot script to define a function. See, and this is one of the greatest uses for AI. You can actually use it to help you learn. This is the keyword in Godot script to define a function. Process. The process function is a special function that Godot calls automatically. It is used for operations that need to happen every frame, such as updating game logic, animations, or handling non-physics related movement. Delta float. Delta is the time in seconds that has passed since the last frame. It is a floating point number and allows you to make operations frame rate independent. For example, if you can multiply delta by a speed to ensure consistent movement regardless of the frame rate. I don't understand what that means, really. Like, so what I'm trying to figure out here is if that's trying to say using delta matches your speed to the frame rate. So it is a floating point number that allows you to make your operations frame rate independent. So then I guess that would be the actions are always going to be going at the same speed. So if I have an action that normally takes 8 frames, but if my PC lags and I only get like 7 frames, it'll still complete it as if it were done in 8 frames, and it will just automatically skip one of those animated frames. That's how I'm reading that. Void. This is a type hint indicating that the function does not return any value. It's optional in Godot script, but improves code clarity. Example usage. The node's X position is updated every frame. The movement is frame rate independent because it uses delta. Process is called only if the node is set to process. This can be enabled or disabled with set process true false. If you need to handle physics related updates, you should use the physics process function instead. Oh, okay. Show message, I'm guessing, is just it's a reference to where we had something up here. Main. No, I guess not, because that probably would have been in the HUD. It's like in here, how can I tell how long this message timer is set for? Create timer. 1.0 timeout. Start button show. I don't know. That one is getting me a little bit. There, but let's see here. So most of that actually seems pretty simple. So when the start button is pressed, it hides it. And when the start game function happens, and then the start game function happens. So this is where it looks like the bulk of our code is. A lot of it's just spaces to keep it organized too. Alright. So going through here. During the game over function, it'll play the death sound, it'll stop the music, it'll stop the timer, stop the mob timer, and it'll show game over. So when it does that, it goes to show game over text there. Okay, I'm getting it. Show game over, show message. I feel like that could just be simplified into being here, right? Maybe not, because this is where we have all of our timers set up. So let's try this. Let's get rid of it there. So it did not work there. So what did that say? No message not found in base cell. Okay, because the show message function is here. So it's just a way to kind of organize it and keep it a bit cleaner. All right, so I think I have a decent grasp of at least the UI and putting this stuff in. So I'm actually going to pull up our good friends Pirate Software, and we're going to take a look at some of their Godot specific resources. There's a lot of stuff in here, but let's look at their pinned messages. Learn to code from zero with Godot. Not quite something I have big interest in. Every 2D node explained in 9. Oh, that might be kind of fun to check out. Let's see, when is that? That was about a year ago. Godot make Pong. Yeah. Let's see if I can pull that up. Oh, that is a pretty cheesy GIF, actually. In case you wanted to see it, though. That's all it is. It's just a GIF that says Godot make Pong. So there's a small tutorial to familiarize yourself with 2D tools. Oh no, that's the one we just did. A list of non-official but good tutorial resources and channels. The Godot video tutorials by GD Quest are well regarded in the community and often recommended as a gentle introduction to beginners. GD's Quest Learn GD Script from Zero is free and open source interactive tutorial for absolute beginners to learn the program with Godot's GD Script language. It is available as a desktop application or in the browser. Some tutorials mentioned below cover more advanced subjects, example 3D or shaders. For video tutorials, we recommend looking on YouTube. There's many great channels covering a wide array of subjects. So, text tutorials. Fine point CGI. Are these like text-based things? Fine point CGI. GDScript website. You make this look too complicated already. It allows for rapid code development and leverages the rich library of available functions within the engine for fast enough speed of execution for the game logic in most cases. Here's the latest tutorial, a parallax background, which we don't need a parallax background. For those who are unfamiliar, a parallax background is one that's basically tiling and resetting and goes an infinite distance in every direction, so you always have a background. At least that's what I think it is. That's how I've always had to utilize it. It's also one that sits a little bit further back, kind of like you might see a skybox in a game, where you can see things adjusting on it in the distance. So, I'm not interested in that one. Oh, that wasn't supposed to pull it up though. Didn't mean to get rid of that. So, do they just link directly to YouTube? They do. Godot recipes by kids can code. If you're new to the game development, start with the Godot 101 Basics section. You'll find an introduction to the Godot application and a step-by-step guide to creating your first project. There is a lot of material to absorb here. Don't feel discouraged, blah, blah, blah. So let's see. Godot 101 Basics. Understanding the tree order. Okay, so this is something they didn't cover. They just told us to do it. You need to understand in what order Godot handles nodes in the scene tree. Tree order is mentioned often in the Godot docs and in tutorials. However, it's not always obvious to a beginner what is meant by this. Generally speaking, the order in which nodes are handled in the tree is in top-down fashion. So that's kind of like what we were spectating, what we saw when we were messing around with our background stuff here over in main. How, because we had the color rectification in second, it is actually blocking the texture ones, which happened first, further in the back. So here's our sample node setup. On each node, we have the following script attached. Function initialize. A node doesn't have a name yet here. Print test root in init. Print name plus tree. Print name plus ready. And then variable test true. Function process delta. If test print name plus process test equals false. Before we talk about the results, let's review what each of these callback functions represents. Good, because I didn't know what the fuck you were saying. So init is called when the project is first created. It now exists in the computer's memory. Enter tree is called when the node first enters the tree. This can be when instancing or when add child is used, for example. So when it first enters here. Ready is called when the node and its children have all been added to the tree and are ready. Okay. Process is called every frame, typically 60 frames per second, on every node in the tree. If we ran this in a single node all by itself, the order would, as you might expect, initialize, enter tree, ready, process. Once we add children to the mix, it becomes a bit more complex and probably needs some clarification. So test root, initialize, child 1, 3, 2, initialize, what? 1, oh, okay, you have child 3 down there because it's the sub-child of child 1. Then test root enters, test child 132 enters, test child 312 is ready. What? So 3. Okay, so would it go down to ready here? Because this one fully initializes and gets ready. And then it backtracks up. Okay, everything in here is then ready. And then jumps down to the next one. And then ready is up number 2. Then child 1, 3, and 2 are ready. 1, 3, and 2. So the test route causes then child 1 to process, which would require child 3 to process, and would require child 2 to process. As you can see, these nodes printed their message in tree order from top to bottom, following branches first, with the exception of the ready code reference. Here's a quote from the node reference. Called when the node is ready, so when both the node and its children have entered the scene tree. If the node has children, the ready callbacks get triggered first, and if the parent node will receive the ready notification afterwards. This leads to an important rule of thumb to remember when setting up your node structure. Parents' nodes should manage their children, not vice versa. This means any code in the parent must be fully accessible, or must be able to fully access any data in its children. For that reason, ready must be processed in reverse tree order. Okay. Remember this when trying to access other nodes in ready. If you need to go up to the tree to a parent or grandparent, you should probably run that code in the parent rather than the child. All right. That makes a lot of sense, actually. So, node communication the right way. I like this website. It's actually giving me a chance to understand. Because before, if I were to go through here, I would have had no idea what they were talking about. But going through, getting this project set up, so I actually have my own reference point in what I did, and places I can go back and double check and be like, okay, I needed this here, I needed this here, I needed this here. It gives me kind of a better understanding of being able to go through and read these things. While still not super clear, I have a better idea of what's going on. So, problem. Your project has started getting complex. You have multiple scenes, instances, and a lot of nodes. Probably yourself writing code like the following. Get node, get parent, get parent, get parent, get nodes, get tree, get root, get node. If you do this, you'll soon find that the node references like this break easily. As soon as you change one thing about your scene tree, none of those references may be valid anymore. Communication between nodes and seeds don't have to be complicated, but there is a better way. Excuse me. As a general rule, nodes should manage their children, not the other way around. If you're using get parent or get node, then you're probably headed for trouble. Node paths like this are brittle, meaning they can break easily. The 3 main problems with this arrangement. You can test the scene independently if you run the scene by itself, or in a test scene that doesn't have the exact same node setup, get node will cause a crash. If you can't change things easily, if you decide to rearrange or redesign your tree, paths will no longer be valid. Ready order is children first, parent last. This means that trying to access a parent's property in a node's ready can fail because the parent isn't ready yet. I don't really understand the function ready, though. I'm hoping we'll get to that. They do. Children very much often make things complicated. So we actually finished our little coding project that we've got here, Snow. So right now I'm actually using what we built, though, and going backwards through some extra tutorials and like teaching tools to try and help me get a better understanding, because none of this made a lick of sense going through it the first time. But now that I've actually had a chance to kind of go through and mess with some of this stuff, like, I'm getting a bit more understanding, and it's been a huge help. kind of like that tell, show, do training method. They tell you how to do it, they show you how to do it, and then once you do it, you get a decent understanding. Maybe not perfect, but we're getting there. So, understanding get node, which we haven't actually used any get node or get parent stuff like that. All of our stuff has pretty much functioned together. The script in the player node needs to notify animated sprite 2D which animations to play based on the player's movement. In this situation, get node works well. So function, process, if speed is greater than 0, get node, animated sprite 2D, play run, play idle. So we actually have an example of this we can go look at. Animated sprite 2D, where are we? We're in the player. There it is. So we have it set up. So if in ours specifically, we have it set up. So if the velocity is greater than 0, then it plays the animated sprite animation. In the parts below that, we actually have it set up to, if the X velocity is greater than 0, then it does the walking animation. So if it's moving left and right, it goes back and forth between these every 5 FPS. So actually, I'm curious about this. We change that to a 1. We change this to a 1. We change it. Does our guy walk a lot faster? No, we broke it. He doesn't walk at all. He just flies around. So let's change this to 3 FPS. Okay, a little bit better. And then what if we change it to like 10 FPS? Okay, so now he walks faster. So the higher the FPS count, the more it functions. And it said it operates at 60 frames a second. So let's set 1 to 30 and let's set 1 to 60. When it's going up and down, it'll be 60 animated seconds. When it's going left and right, it should be 30. So 60, it's basically playing both animations at the same time. So 60 is way too fast, because it's putting both animations on the screen. Although I do like 10. We can make it look like he's walking faster. Like 5 was a solid okay to start, but this offers a bit more player feedback and clarity. So he kind of looks like he's swimming more this way. Now, let's get into a fun one. Let's go over to the mob. How can I get to the mob's stuff? So mob animated sprite. Let's change this to 20. We'll change this to 10. We'll change this to... yeah, we'll keep it at 3. So then the mobs should be doing different stuff. Yep. We got their little leggies moving at different speeds now. Cool. like the guys with little legs don't, they need to swim harder. The people with bigger legs don't need to. Look at that. The crossfin people are medium. The twin-legged people are the fastest. And the giant bow-legged people are much slower. Because they... I mean, that just makes sense physics. Or with physics, right? Cool. Alright. That's awesome. I want to pull this up and make notes of that. By changing the speed of the legs, or by changing the, what is it? Animation speed of mobs, we can get each instance, oh man, I cannot type today. We can get each instance of the mob to look like they're animated differently. 60 FPS animations will all animations show at the same time, since Godot renders animations at 60 FPS. Well, I actually need to run to the restroom real quick, so I'm going to run a quick set of ads so we can get the next ad that's about to show up here disabled, and then I will be right back.
Everyone deserves a fast and reliable connection, one that helps better their everyday through the things they value most: friends and family, education and career. A connection that opens pathways to opportunity and builds roads to a better future. At Spectrum, we're committed to delivering just that every single day. Because with the right connection, anything is possible. That's Life Unlimited. That's Spectrum.
Okay, I'm back. Let's see. We are back. I want to keep reading up on this website because it's actually been pretty helpful so far. So, a better way. So, the downside of that approach, though, is that if you specify the node path, and if it changes later, you'll have to edit that code as well. So instead, you can use the export feature to directly select a node. So export variables animation from animated sprite 2D. In this method, if you can assign the value of the variable directly in the inspector by choosing this node. In this method, you can assign the value of the variable directly in the inspector by choosing the node. Okay. So using signals should be used to call function on nodes that are higher in the tree or at the same level, siblings. You can connect a signal to the editor, most often for nodes that exist before the game starts, or in code for nodes that you're instancing at runtime. The syntax connecting a signal is signal name connect. So looking at this, you may be thinking, wait, if I'm connecting to a sibling, won't I need a node path like ... sibling? While you could do this, it breaks our rule above. The answer to this puzzle is to make sure that connections are made by the common parent. So if I had like something that I need to connect the texture and the label to, it would go into box. Note that the UI is an instant scene. We're just showing the contained nodes. This is where you often see things like get node, blah, 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 text equals strength, which is what we want to avoid. Instead, the player emits a health change signal when it adds or loses health. We need to send that signal to the UI's update health function, which handles setting the label value. In the player script, we use this code whenever the player's health is changed. I wonder if that would be something that we add onto this next attempt. We see if we can go through our little game and add health for the little guy. See if we can make it so that he dies after 3 hits or something instead. So using groups. Groups are another way to decouple, especially when you have a lot of similar objects that need to do the same thing. A node can be added to any number of groups, and membership can be changed dynamically at any time with add to group and remove from group. A common misconception about groups is that they are some kind of object or array that contains node references. Groups are a tagging system. A node is in a group if it has that tag assigned from it. The scene tree keeps track of the tags and has functions like get nodes in group to help you find all nodes with a particular tag. So let's consider a Galaga space shooter where you have lots of enemies flying around. These enemies may have different types and behaviors. You'd like to add a smart bomb upgrade that, when activated, destroys all enemies on the screen. Using groups, you can implement this with a minimal amount of code. First, add all enemies to an enemies group. You can do this in the editor using the node tab. So function ready, add to group enemies. So let's assume every enemy has an explode function that handles what happens when it dies. Playing an animation, spawning dropped items, etc. Now that every enemy is in the group, we can implement our smart bomb functions like this. Get tree, call group, enemies explode. Okay, cool. So that's basically a way to add like an organization system to it. Using owner as a node property that sets automatically when you save a scene, every node in that scene will have its owner set to the scene's root node. This makes for a convenient way to connect child signals up to the main node. For example, in a complex UI, you often find yourself with a very deep, nested hierarchy of containers and controls. Nodes that the user interacts with, such as button, emit signals, and you may want to connect those signals to the script on the UI's root node. Here's an example. Button 1, button 2, button 3. The script on the root center container has the following functions, which we want to call whenever any button is pressed. So, this is just a way of saying button name was pressed. Here we go. Understanding delta. The problem child that has been in my code. The delta, or delta time parameter, is a frequently misunderstood concept in game development. In this tutorial, we'll explain what it does. To illustrate the problem, let's consider a sprite node moving across the screen. If our screen is 600 pixels wide, and we want the sprite to take 5 seconds to cross the screen, we can use the following calculation to find the necessary speed. Just 120 pixels a second, yeah. We'll move the sprite every frame using the process function. If the game is running at 60 frames per second, we can find the per frame movement like so. So 2 pixels a frame. Notice the units are consistent in all the calculations above. Always pay attention to the units in your calculations. It'll save you from making mistakes. Okay. The trouble begins if there is something else occupying the computer's time. This is called lag and can come from a variety of sources. The cause could be your code or even other applications running on your computer. If this happens, then the length of the frame might increase. As an extreme example, imagine that the frame rate is halved. Each frame took 1/30th instead of 1/60th of a second. Moving at 2 pixels a frame, it's now going to take twice as long for the sprite to reach the edge. So when using the process function, it automatically includes a parameter called delta that's passed in from the engine, which is used for physics-related code. This is a floating point value representing the length of time since the last previous frame. Typically, this will be approximately 1/60th or 0.167. With this information, we can stop thinking about how much to move each frame and only consider our desired speed in pixels from the above calculation. Cool. I like that. So you need to save and load local data between game sessions. Godot's file I/O system is based around the file access object. You open a file by calling open. Hold on, I think someone is in my house. Need to go make sure because I thought I was alone. Okay. So, someone was just home. I wasn't expecting them to be. Alright, so saving and loading data. User data should only be stored in the user path, while res can be used when running from the editor. When your project is exported, the residual path becomes read-only. The second argument after the file path is the mode flag. So, let's see. File access write. Open the writing, creates the file if it doesn't exist, and truncates if it does. I don't know what truncates means. Read write. Open the file. Open for reading and writing. Doesn't truncate the file. Open write read. Open for reading and writing. Creates the file if it doesn't exist. Truncates it if it does. Alright, what is truncate? Shorten the duration or extent of. Okay. Weird, but sure. Alright, you know what? I don't need to deal with this. It's going to be a long time before I get to the point where I'm actually, like, saving data. So, let's take a look at something different. I don't think we actually need this for anything, right? Yeah, that wasn't being used for anything. So, let's say we wanted to turn this into a vampire survivor. There's a couple things we need to do. Let's pull up our notepad. So, to edit it into a VS game, because we're pretty close there. It spawns enemies, they run in a random direction. First, we need to add We don't need health quite yet because we can make everything just a one-hit die. But we need an attack. This needs an animation. Or this needs art and sound. We don't technically need an animation yet. We can make it just a box that appears, play a sound, and then disappears. Then we need to set up collision for the box. Actually, we don't even need it to do this. What if we start with just something like the... let's start with something like the garlic attack, where it just deals damage if it gets close. Oh, that's going to make it very hard for it to actually hit our character, though. We still want them to be able to die. So we need an attack and a collision detection on the attack and enemy. And we want the attack to trigger automatically every 2 seconds. So let's look at how we can take something like this basic thing that we have here and add an... I guess we want to add an animation to our character, right? So how can we do that? So let's see what this does.
You have an animated character, and you want to make a melee attack, such as swinging a sword or punching. And this could be in 2D or 3D. Our solution here will be in 2D, but the process will be the same for 3D. Here's how to make it work. So we're starting here with a character who has an attack animation. And whenever the sword goes out, we want to detect that it hit something. And we'll want to do that with an area 2D, but we only want it to be active during the frame when the sword is swinging right there, but not after. And so we're going to do that with our animation player so we can make sure that that enabling and disabling of the area will match the frames of the animation. And we can also do that with the second attack here, which has a slightly different pattern. So what we're going to do is, as a child of the sprite, I'm going to add an area 2D. And I'm adding the area 2D as a child of sprite because when we move the sprite, we're using the scale and setting it to -1 to reverse direction when we move to the left. So this way, our hitbox for our sword will flip also when we flip the character. And so we're going to add a collision shape to this, and we're going to use a rectangle. And so this is the hitbox for our sword, which is obviously going to need to be a bit smaller. And we can advance the... There we go. We can advance the animation player until we see it where we want it to be, right? And so we can see it starts coming out, and maybe we'll pull this back here. Yeah, and so that's the area something will need to be in for the sword to damage it. And then over here on the very first frame, we want to make sure that this collision shape is disabled, and we'll keyframe that, and then we'll advance to the attack frame and turn disabled back off, and we'll keyframe it. Then we'll leave it active until we get to here, and then we'll disable it again. And so now when we play the animation, you can see it get enabled while the sword is going forward. Now we need to connect this up. So I'm going to rename this area 2D to sword hit, and I'm going to connect its area entered signal. And so this is going to go to our player script, which already has the code to do its movement, which I'm not going to go into. You can see another one of my tutorials for that. but in our area entered, all we want to do is see if the thing that the sword hit is a hurt box. A hurt box is an area that I can add to any object that will cause it to take damage.
Alright, so let's back up. He does his melee attacks in the animation frame. We don't have any animation frame to our attack.
So what we're going to do is, as a child of the sprite, I'm going to add an area 2D. And I'm adding...
So as a child of the sprite, we add an area 2D.
Adding the area 2D as a child of sprite, because when we move the sprite, we're using the scale and setting it to -1 to reverse direction when we move to the left. So this way, our hitbox for our sword will flip also when we flip the character. And so we're going to add a collision shape to this. And we're going to use a rectangle. And so this is the hit.
Collision shape. Yeah, rectangle sounds fine.
Box for our sword.
What's the select mode? Nope, I just want to select this. How can I select just that? Haha, we can do it like that. And now we'll group them all back together. So if I try to grab this, the whole thing goes. Okay. So we've got our collision shape.
Which is obviously going to need to be a bit smaller. And we can advance the... There we go. We can advance the animation player until we see it where we want it to be, right? And so we can see it starts coming out.
No, so he's actually got something here called an animation player attached to the adventure. So let's actually back up here because I feel like he's too far ahead. Because we don't have an animation for this.
Team's switching off.
See if we can learn something.
That games rely on two kinds of collision shapes to make melee attacks feel great: hitboxes and hurt boxes. hitboxes deal damage while hurtboxes receive damage. In this video, you will learn to code both in Godot. We'll start by coding the hitbox, then the hurtbox, and we'll use them to deal damage to enemies. This video is sponsored by our course, Learn to Code. What we need to do is to create new kinds of nodes that represent hitboxes and hurtboxes. I'm going to double click on my sword to open the corresponding scene and want to do something like this. When I press Ctrl A, I want to be able to search for a hitbox node and just create it. We have one done in this project, but we're going to code our own from scratch. To achieve this, we have to create a script file. So I invite you to right-click on the practice folder, click New Script, and enter a name like my hitbox, which I'm going to copy, and click Create to create the script. Double-click the script file to open it in the editor, and the first thing that we want to do is to set the type to extend area 2D. Areas are the basic kind of node that detects physics interactions in Godot. Like the player is in front of a chest, you press a key, you open the chest. But they are perfect for things like hitboxes and hurtboxes. Then to create nodes based on this script, we have to create a new line that uses the class_name keyword, followed by the name we want for our node. And as soon as you've done that, you can already go in the editor, press Ctrl A, and search for my hitbox, and you'll see the node is right there. All right, so let's keep coding. We want to do two things. First, we're going to create a variable to represent the base damage of our hitbox, because the hitbox is responsible for dealing damage. So it should hold the damage. And then we're going to change the default properties of that node, and that's why we're making a script. We'll keep it simple in this video, but you can build upon what we'll do here. Now, let me create an area 2D node to talk about physics, layers, and masks. If you go to the inspector on the right and expand the collision category, layers and masks appear. These control what this node will collide with. And for our hitboxes and hurtboxes, what we want is for them to just detect one another. Precisely, we want hurtboxes to detect hitboxes, and that's it. And so typically you change these layers and masks to filter the collisions in your game, right? We named the first layers in this project for you. So layer 1, we called it the game world, and layer 2 is going to be for hitboxes, right? And so what we want precisely is for the hitbox to be on layer 2 and to have no mask. Why? Because the layer represents the category of physics objects this node is part of, and the mask represents the category of physics objects it will detect. That's the general idea behind these two. So if I go back to my hitbox script, I'm going to do these two things. Collision layer, I want to set it to layer 2. Now, you have to be careful about that because collision layers and masks work with binary numbers. And so you want to set it to layer 2, you want to assign the value 2 to the collision layer property. Now, the way you know which value to use is by hovering over the collision layer.
Hovering?
You can see it says bit 1, the value is 2. But it worked with powers of 2, so bit 3, or bit 2 rather, would be value 4, and so on. Then it gets to 8 and 16 and so on, right? And for the collision mask, sorry, I'm gonna get back to my hitbox script, and for the collision mask, we want a value of 0, which will turn off all the collision masks. So that's our hitbox script done. Then we need the hurtbox, the one.
So can't you just do like a collision box though if you're just testing for collision? So let's jump back and try and follow along now.
A key, you open the chest. But they are perfect for things like hitboxes and hurtboxes. Then to create it. We have one done in this project, but we're going to code our own from scratch. To achieve this, we have to create a script file. So I invite you to right-click on the practice folder, click New Script, and enter a name like my hitbox, which I'm going to.
So let's take a look. Current animation. It has none. So let's go to, where is it? Player?
Find your favorite TV shows on YouTube. Get Paramount Plus, Stars, MGM Plus, and more on YouTube.
Oh, hey. Cool. So we accidentally added that. Are you playing Mario 64? Hold on. I just realized YouTube may be screwing up. Nope, it was just on a frozen spot. Okay. We got an ad starting in 50 seconds, so I'm going to go ahead and run my ad real quick while I try and look at this information a little bit. Be back soon. Are we back? We are. Alright, so we are going to take a look at this real quick. So he's creating a script.
Copy and click Create to create the script. Double-click the script file to open it in the Edit tab.
It seems like a bit older version because I don't know why he's doing a practice folder or anything like that. I feel like that's part of a larger tutorial that we're just trying to get a piece of. So let's try taking this out.
Hello, this is Brano, and today I want to talk about the Survivor's Clone tutorial series. So before we begin, this tutorial is done in Godot 4.0. Godot, as you probably know, is a free and open source game engine. If you haven't downloaded it yet, you can go to the Godot website,
Flashbang.
downloads, and download the engine. As of recording, the engine is still in beta, so if you are watching this earlier, you can download the latest beta build by clicking on Download Repository, going to 4.0, and downloading the latest beta build. So what's in the tutorial? This tutorial is heavily based off a game called Vampire Survivors, which is heavily based off a game called Magic Survivors, which is heavily based off a game called Crimson Lands, which is heavily, you get the point. It's a game where you go around killing enemies with automated attacks. You can collect experience, level up and upgrade your character until you become an unstoppable killing machine. It's a very fun game which you can buy off Steam for $5, and it seems like everyone else is trying to make their own Survivors clone, so why not use this tutorial as a good starting point? Either to make your own Survivors clone or to learn the Godot
This looks pretty
engine.
scuffed right now,
In
though.
this tutorial, I'll teach you how to make a player character with 3 distinct attacks, 5 distinct upgrades, 5 different enemies, a main menu, a graphical user interface, a level up and upgrade system, all within a 5-minute gameplay loop. While this tutorial is intended to be for Godot beginners, you should still have a very basic understanding of programming before doing it. If you understand what an if statement is, what a for loop is, and what a function is, then you qualify for this tutorial. If you haven't done programming before, there is an absolutely excellent and free Programming 101 tutorial in Godot's scripting language, GD Script, that has been made by a channel called GD Quest. Link in the description. The
GD
type
Quest
of
was one that was
teaching
linked to
method I'm
me
going
by
to be
quite a few
doing
others
is
as well.
Teach practical first, theory second. In school, you probably experienced theory first and practical second, and if you've done game dev tutorials in the past, you probably know how difficult it is to understand practical and theory at the same time. I always found that I didn't really understand the theory until I did the practical work, and I feel like I'm not alone with that. I will be explaining my actions while I type, but if you don't get a concept right away, don't worry. I will be doing a theory time at the end of each episode. This will comb over the code we have written and explore some nuances after
He's definitely
each
going a bit
episode.
slower than some of the other people
Hopefully this means
that are
that
trying
when
to
the video
teach.
ends, you don't just have working code, you actually understand how the code works and how to adapt it. If you end up liking this style of teaching, please let me know in the comments below. There should be 15 episodes in total, and if episode 1 doesn't show up in your recommended feed, you can find it in the description below. In addition, I will have a complete version of this project on GitHub for download below. This tutorial does contain assets that are not my own, but all of them are downloadable with the Creative Commons license, specifically CC0. This means that everything in the tutorial is yours to manipulate and use for whatever you want. Otherwise, to start your journey, go to the description below if episode 1 doesn't show up in your recommended feed, and click on episode 1 to begin the How to Make a Survivors Clone in Godot tutorial.
Alright, sure.
Stains are certain, so is the power.
So this is kind of what we wanted to try and make.
Start shooting in 3 weeks.
So I wanted to see what we kind of need to do as far as like setting up some of the automated attacks and stuff.
In this episode, you will learn how to make a moving character. Hello, and welcome to How to Create a Survivors Clone in Godot 4.0. My name's Brano, and this is going to be the first episode of a step-by-step tutorial on how to create a Survivors clone. So if you haven't done it already, you can go into the Godot website and download Godot. This tutorial is going to be in Godot 4, so if Godot 3.5 is still the latest version, you can just go into the download repositories. When it brings me there, go into 4.0 and download the latest build of Godot. It's pretty simple, it should just be in a zip file. Now, when you go there...
Oh, I don't want that.
You should be able to open up the Godot free beta.exe or Godot 4 episodes go on. So the way Godot works is that it has a node structure, which think of it just as containers, and those containers have specific attributes. on them. At the moment we're in a 3D scene, but to begin our tutorial, what we're going to be doing is adding a 2D
Let's go
scene.
the fucking T1.
Now this adds a node called Node 2D, and what this is, it's just a place within a 2D space. So you've got various different attributes towards it, which we're not gonna worry about at the moment. All we're gonna do is do a right click and click on rename. You can also use F12, F2 if you want.
No, not that.
And we're just gonna name this world. And then, as this is a node and it's a container, you can add new nodes to it, and you can add various nodes types. There are a lot of different nodes, and it's very easy to be overwhelmed. I would just focus on learning the nodes that you need to know and ignoring everything else. So what we're going to be doing is, instead of going through this big list and trying to find a sprite, we're just going to be typing in sprite. And we are going to be using a sprite 2D. So we're going to be clicking on create, and we now have a sprite 2D node.
All right, easy enough. Especially since we did a little bit of this stuff. We're going for a 2D scene. We're going to add a child. Sprite 2D. Voila! Our stuff matches.
Which we are then able to go into textures. I'm just going to close the enemy, and I'm just going to make a background. So this is going to be a sprite with a background. I'm going to call this sprite background, which can be done with a double click. And then what we can see is that we have a fairly, like, just one tile of a sprite. Now, if we want to spread this out, we can, but that kind of stretches the texture and it looks really bad. So instead what we're going to do is we're going to be using something called a...
So we need a background for our game. So let's start with there. Yeah, I'll pull this up. We don't need this. You know what? Let's make our own. We'll keep it grass-based. So we'll fill it in. Let's get a little bit darker green.
All season long on a variety of networks.
Yeah,
NFL
soft
Sunday
green.
Ticket with YouTube TV.
We'll get a pencil.
Get it now.
We'll draw little
Tons of
grass
stars of
tufts
surprises
everywhere.
every time.
Oh, that one looks terrible. Look at that. It's a beautiful tuft of grass. We're not worrying about pixel art yet. We're going to learn that here in a little while. But no, we just want this. And we're going to keep the edges clean so that it can tile over itself real nicely. Save as PNG? Why not? We're going to go to our desktop. Godot. Survive stuff. We need a new folder. Art. Save. Oh, we didn't want to save that as untitled, though. Grass. Because we're going to touch some eventually. Alright, so we need to go to... Let's see. How did he do that?
Sprite 2D. So we're going to be clicking on create. We are then able to go into textures. I'm just going to close the enemy.
Yep.
And I'm just going to make a background. So this is going to be...
So he just clicks and drags it over there.
Sprite with a back...
Oh, look at that. That came out a lot bigger than I thought. Oh well. See, yeah. Let's delete that. Oh no, I didn't want to delete Sprite 2D. I wanted to just delete the grass texture from here. Clear. Let's make it 1/4 as big. Okay, you can't really see the stuff I made, but whatever. We'll redraw our grass. Yes, overwrite.
Find your favorite TV shows on YouTube. Get Max, Stars,
We're going to go back to our sprite, copy the texture to here, and it's a much more manageable size for what we're trying to do at least. Not those, wrong one.
Background, I'm going to call this sprite background, which can be done with a double click. And then what we can see is that we have a fairly, like just one tile of a sprite. Now, if we want to spread this out, we can, but that kind of stretches the texture and it looks really bad. So instead what we're going to do is we're going to be using something called a region. And to use the region, all we need to do is click on enable region. It will disappear, but that's because we don't have really a rectangle. And what this does is we're able to select like a region for our sprite. So if you click on edit region and drag and drop, it'll kind of spread out.
Whoa.
Now, it's kind of messed up.
All right. So where did he start that at?
If we want to spread this out, we can, but that kind of stretches the texture. Something called a...
So region right there.
Region. And to use the region, all we need to do is click on enable region. It will disappear, but that's because we don't have really a rectangle. And what this does is we're able to select like a region for our sprite. So if you click on edit region and drag and drop, it'll kind of spread out. Now, it's kind of messed up at the moment.
It is
visually.
Not pretty.
But what we're able to do is, and I forget exactly where it is, yes, texture. We're able to change some attributes of this texture. So at the moment, the repeat is set to inherit. But if we were to able to set this to enable, it's going to repeat the texture. You'll also see that this texture is a bit blurry, so we can also set this to nearest. You can set it to linear. You can set this to nearest mid map, and there's a couple of different options. But with inherit, what you may find is that the default, so inherit is just inheriting the project settings. And if you want to ever change that, you can go into your project settings.
Do we need
go to texture and change the project settings so that the default texture filter is linear. Now, I think it should be nearest because I don't want my sprites to be blurry, but I'm also going to leave the repeat texture as disabled, and this is just going to be the default. Now, I'm going to be honest with you, as a background being really sharp, I think it does take away from the game. So I'm going to change this background and set this to not nearest, but linear. And I think this does actually make better. Now, if I want to make this really big in a deterministic way, I can just set the X and Y coordinates as well as the W and the height coordinates, which is I guess their way of just saying negative x, negative y, positive x, positive y. We can just type in like, let's just do negative 4,000, negative 4,000, 4,000, and 4,000. And you get and by using the scroll mouse wheel, you can scroll out and you'll get a very
And that's under
big
region
texture.
and sprite 2D.
And this is just
So region. Okay, cool. Right now it looks like it's set to 1260 by 720. Not quite. Oh well.
just what we're going to be using for our game. Now,
Give me 1 second though. I actually got a phone call I needed. Never mind.
I'm going to do a Control S. You can also do a scene and save scene, and we're going to Control S, and we're going to save our world scene, which is a 2D node with a background sprite as a child. I'm going to create a new folder by right-clicking and clicking on New Folder, and I'm just going to call this folder World. And we're just going to save our world within that world folder. Pretty simple. Now, we should probably add a character to this. So I'm going to click on Add New Child. And what I'm going to do is I'm going to add a character body 2D.
Okay. Child. Character body 2D.
Which is effectively just a character that runs on code. So I'm going to rename this to player, and instead of editing stuff within the character body 2D, I'm going to make this character its own scene. And what creating this does is it makes the character really its own specific types of nodes with its own children. So I'm going to click on Save Branch as Scene. And I'm also just going to create a new folder called Player. So I'm going to click on that, Player, and to go into the player.
So why do we do that though?
Click on Open in Editor. Now what this does is it means that any change I make within the player scene is going to be apparent here. So let's add a sprite 2D.
Wrong one. Sprite 2D.
And let's add the player sprite 2D. Now, there's 2 frames of animation, and I only want there to be 1, so I'm going to increase the horizontal frames, so I only get one sprite for my player. Now,
That's an interesting way to do it. Okay, so let's go to our paint thing then. Let's make it a little bigger. Let's go like right there. We're just going to do a stick figure.
Your favorite movies are on YouTube. Enjoy the latest releases.
That's all we need. That's going to be our player character, because we are doing this absolute minimal. as best we can. But we want to make it so he has an animation too.
Get Paramount Plus, Stars,
And since I am not good at actually measuring stuff,
find your favorite movies and TV on YouTube.
I'm hoping that's about halfway. And then we're going to change his arms and legs so that we can see if he's actually animating stuff. Just to make it look a little different. Kind of looks like he's trying to fly, but I think we want this a little bigger. It looks like probably isn't quite even. All right, save as PNG, all lowercase. Keep our naming conventions the same. Player. Now if we go in here to art, player. It is white though. You remove the entire thing. You remove the background, so that kind of broke our stuff. Maybe we can make them with just ovals. All right, there's person one. Heads aren't the same size. Not important for this, though.
Find your favorite movies on YouTube. Get AMC Plus, Paramount Plus, Max, and more on YouTube.
And let's put this so that's kind of closer towards the middle. Yep. Which properties, pixels, sure. I don't like that it's removing the background from them, though. Yeah, see, it's still a white background. I want it invisible. Ah, damn it. That tool doesn't do what I think it does. I'll try saving it as player, see if that changes anything. Oh, no, that's for the work we're doing on the YouTube stuff. Nope. I thought I was able to make stuff in here with no background pretty easily. Ah, but you know what we can do, though? Remove.bg. That was it. Yeah, I guess we'll have to do it this way. Yes, I'm going to replace that one. We're going to go in here. Now, we should have our no background person. Cool. We got our world, we got our player.
Your favorite TV shows
If I save this horizontal, and I only want there to be one, so
animation frames.
MGM Plus and more. Find your favorite movies and TV on YouTube.
I'm going to increase the horizontal frames, so I only get one sprite for my player. Now, if I save this,
Teams switching off.
Shut up.
You'll see that the player now has a sprite associated with it.
Cool.
Now, if you wanted to play a scene, you can click on Run Project. It needs to load a particular scene for the initial side, so we're going to select Current when we're on World. If you are currently on the player, you can just go onto Select and make sure that World is selected. So we're going to...
So we're on World. Okay, our guy's in the corner there. We're good.
Click on that, open, and you'll find that we have a very large scene and our player is in the top corner doing nothing. Now, this is a bit big for us, and we want this to be a pixel styled of game. So what we're going to be doing is we're going to go into Window. I'm going to turn on is selected, so we're going to click on that, open, and you'll find that we have a very large is to be a pixel
where does he go to select this stuff?
For us, and we want this to be a pixel
project settings
styled of game. So what we're going to be doing is we're going to go into Window. I'm going to turn on advanced settings, and I'm going to be changing the viewport width to 640 by 360.
Ah, that's so tiny though.
And we're going to be setting the stretch mode to canvas item. I'll just show you what happens when we don't do that.
Okay, so project settings. His was pretty small.
So when we play this, we'll see that we have, once again, a very zoomed in game. However, when we do the stretch mode canvas item, we still have the same thing, but when we do window width override, and let's just make it double, so 128 by 720, which is double.
All in one place.
You'll see that it's a lot more reasonable and zoomed in to.
Oh, that is weird. I can click on that and then drag left and right with my mouse. So how did he change that? It was under window stretch.
Item. I'll
Canvas?
just show you what happens when window width override. We still have the same thing, but
it just makes the screen bigger rather than close up on the next step.
When we do window width override, and let's just make...
I don't think I have that on mine. It doesn't look like I have that option.
We still
he
have
does.
the same thing, but when we do window width override, and let's just make it double.
Resizable, borderless, always on top. Did they just get rid of that?
So 128 by 720.
Oh no, because he turned on the advanced settings. That's what it was.
That switches double. You'll see that it's a lot more reasonable and
my sizing is not quite right. Zoomed us in a lot though. What size did he make his first one?
the stretch mode when we that we have once again a very zoomed in game. However, when we
I don't know my ratios, okay?
we do the stretch mode canvas item, when we will see that we have what happens with
640 by 360.
Your favorite movies are on YouTube. Enjoy the latest releases. Get Paramount Plus.
I guess it's just half of that, so
MGM Plus,
yeah.
and more. Find your favorite movies and TV.
Oh, that is much more zoomed in.
when we don't do that. So when we play this, we'll see that we have once again a very zoomed in game. However, when we do the stretch mode canvas item, we still have the same thing, but when we do window width attach a new or 20 that switches double into what you would be playing. Now, we don't have a movement script for our player, so we need to add our code. Now, the best way to do this is to click on the player, click on attach a new or existing script. So we're just going to be adding the player and clicking on create. This is going to have a bunch.
We did this before. Where am I? This one. Player, attach script.
Of code immediately, but yeah, we're going to get rid of all of it and create our own movement system. So before we do this, I'm just going to set the motion mode to grounded. So if we So because this is going to be a top-down view, what we want to do this... So what we want this kinematic body to understand is that it's going to be floating. Grounded just means it's expecting there to be a floor that it falls into gravity. Think of like Super Mario Brothers, where you fall down to the bottom of the screen when you jump. Since we're not jumping and it's bird's eye, we want this to be floating. So I'm just going to do a Control S there.
Give me 1 second.
And I'm going to...
I have someone here. I'll be right back.
You're watching a toothbrush play Billie Eilish. But did you know that there's a YouTube Music app where you can also listen to the EDM version, the ska version, and of course, the original version? Duh. Get YouTube Music Premium.
Alright, I am back.
To start typing up our movement script. So I'm going to be making a variable called movement speed. And this is going to be equaling 40.0.
Variable movement speed. $40.0.
We don't need to declare its type. You can if you want, but there's a lot of interpretation that happens within GDScript, and it's a fairly easy language to use because of that. Now, we need to have our game loop, and Godot has two primarily game loops. We got process, so we've got function process delta, which is every single frame, and then we've got physics process delta, which is every single physics frame. So every single physics frame is defaulted to one every 60th of a second, and this is what delta will primarily be, 1/60th of a second. And within this physics frame, we want to detect how our player moves. So I'm just going to create a new function called movement. So the physics...
We're using physics process delta. Function movement not found in base sub. Yeah, we're getting there.
Physics process is a Godot defined function, and the movement function is going to be our own personal function. You'll learn sort of what the Godot defined functions are as time goes on, but for the moment we're just going to be focusing on our movement. So the way we're going to be doing this is by detecting what movement keys are being pressed. And before we do anything, we have to create our movement controls. So by doing this, we're going to go into project settings, go into the input, and the movement function is going to be our own personal function.
Oh, it's not underscore movement, it is just movement. Does that change anything? No, doesn't look like it.
You'll learn sort of what the Godot defined functions are as time goes on, but for the moment, we're just going to be focusing on our movement. So the way we're going to be doing this is
so he's got
by
that same
detecting what movement keys are being pressed. And before we do anything, we have to create our movement controls. So by doing this, we're going to go into project settings, go into the input map, and we're going to add a new action. we're going to add an action called up.
So many tabs. Alright, so we did this earlier today.
Your favorite movies
Input.
are on YouTube.
Action
Enjoy the
up,
latest releases.
This fight is mine.
down, left, right.
Welcome to the
Does he do diagonals
gonna
as well?
Press the enter key to add. Down, left, and
Paramount
right.
Plus, Stars,
And
MGM
these
Plus,
actions need to
and
have
more.
keys assigned to them. So
Find
I'm
your
going to
favorite
click on
movies
add
on
event.
TV on YouTube.
And I am going to do it by, I believe it's filter by event. And I'm going to click on W, the physical key. And we want to make sure that physical key code is pressed because people can have keyboards with different letter variations on them. And we want the W key for most keyboards to be used. So click on OK, and now W will correspond to the up action.
Alright, so same thing we did before. W. S. A. And D. But we also want to make it available for up, down, left, and right. And then we're going to add our controller support in as well. So, up, down, left, right. Then joystick, up, down, left, and right.
Gonna then use down as S. A.
But we didn't check for the
left,
physical keys, if that's a thing.
and D for right. Now we just click on close. That's all.
We don't have that option. Okay.
So in our movement function, which is going to be processed every 60th of a frame, we're going to create a variable and we're going to have this called xmov. And we're going to make this equal to an input. And input is just a way of Godot saying something happened, the player did something. So in our input, we're going to get the action strength. And this is going to be a 0 or a 1 value. So if I am pressing right, it is going to return a 1. If I am not pressing right, it is going to return a 0. And what I'm going to do is I'm going to do right subtracted by left. So input.get action strength. And we're going to be doing left. So pretty much if I hold down D, it's going to be 1 minus 0 if I'm not holding down A. If I'm holding down both A and D, it's going to be 1 minus 1. And this is just going to determine where we move. And then we're going to be doing the same for the Y axis, which is input dot get action strength. Now, the Y input in Godot in a 2D space is the opposite of what you would expect. Up is actually a negative value, and down is a positive value. This can get
We noticed that last time.
This can get a bit confusing. So we want down to be our positive value, and we want up to be our negative value. This is just something to keep in mind. I don't know why this was done, but it just is. And it's something that...
So he's doing this all into one or two set of variables right here, it looks like.
You just continually have to remember.
Which I don't think we did that in our previous version. Save all scenes. No. Quit to project list. So when we did this, let's double check how we did movement before. Oh, wait, where's our HUD? Oh, it's over here under main. And then we have the scripts there. Okay. So scripts, we have our player. Oh yeah, I don't know that we ever tested that. So, what happens on here when we press left and right at the same time? So it just freezes in place. Okay. We'll try it the way he's doing it. But he's making long lines of code that doesn't seem very... What's the word I'm looking for? Optimal? Minimizes the lines of code, but... I'm surprised how light this is on my PC, though. Even while streaming, Godot is, like, super soft and not overloading it at all. I didn't have the same issue when I was trying to learn Unreal Engine 4. Alright.
So, once we got that, we want to do another variable called mov. And mov is just short for movement. And we're going to make this a vector2, which is just a placement on a graph. So we're going to make that vector2 ymov. So the x value in the vector2 is going to be xmov, and the y value is going to be ymov. And then what we're going to be doing is we're going to be setting our player's velocity, and this velocity is just kind of where it's going to move. Where is the movement going to be directed to? So velocity equals mov dot normalized. We'll get into normalized with theory time, but just feel like it's there. And then we're going to multiply that by the movement speed.
So he's actually creating a movement speed stat, which is different because the other one that we made was focusing on just doing, okay, we're checking for movement and we're going this way. So I am actually going to just tab over and copy all of this stuff real quick. So we've got variable x move, var x move equals input dot get action strength, right? Ooh, nope, right? Minus input dot get action strength left. We got the same thing we're doing here, except it's going to be variable y with down and up. Then we have variable move equals vector2 x move, comma, y move. And lastly, we have velocity equals move dot normalized plus movement speed. But we want it lowercase, yes.
So if I have a vector of 40 x 0 y, means that I'm going to be moving 40 pixels to the right every single frame. And then we're just going to be doing a move and slide. Now, move and slide already has delta associated with, oh, sorry, I did movement speed, sorry. move and slide. So move and slide is a Godot function specifically for the character body 2D, and this is what causes our character to move. So now if I am to save this and run, I should have a moving character.
Is that true? Invalid operator vector 2 and float and operator plus. So it crashed on us. So we had a typo somewhere.
For the character.
Oh, times move speed, not plus. Invalid operands vector 2. X move, comma Y move. You don't have higher quality that we can get, do you? Move dot normalized. Physics process delta float. Oh. He's just got delta. Yeah, our guy's moving around. He moves slow as shit, but he's moving. That's a big sprite. Oh, not important right now.
The body 2D, and this is what causes our character to move. So now if I am of a moving character, we'll run through our code during.
So I don't like how slow he is though, but let's try changing this to 150. See if that moves him at triple the speed. Yeah. Okay. Simple enough. All right, so we got that for now, and we're moving on.
Time, but this is the end of the episode for how to make a moving character in a Survivor's clone.
All right, well, that's the end of that tutorial. What else is he going over there? I don't know what this is, but that looks weird. We might go over that here in a bit. Well, let's go ahead and take a second. See if we can fix some of our stuff. Sorry, I get a phone call. I will be right back. All right, we're back. Theory time.
The way our code works is that every 60th of a frame, we run the movement function. The movement function will check what action is being pressed down and assign a value of 1. In the case of x_mov, if right is being pressed and left is not, xmov is just 1 minus 0, ymov would be 0 minus 0. We would then put this into a vector2 variable that is pretty much just a direction. So in our case, this would be vector2 1x, 0y. The first coordinate is x, the second is y. In order to move a character body 2D object, you need to set the velocity. So with the direction of right, which is vector 2, 1x, 0y, we multiply that by the movement speed, and we get vector 2, 40x, 0y. After the velocity is set, we use the move and slide function to get Godot to know that we want our character to move. You may notice that there is a normalize function at the end of mov, so we will need to talk about that. You may also be thinking, well, if I'm setting the velocity to vector 2, 40x, 0y, why isn't going 40 pixels a frame? The character is certainly not moving that quickly. We will talk about why in the next couple of topics. So you may have played a game in the past where moving diagonally was quicker than moving in a linear direction. This is because a vector of 1x, 1y is further away than a vector of 1x, 0y. You can prove this with Pythagoras' theorem to see why this speedup occurs.
We don't need that.
So what normalization does is it takes each vector and divides it by the largest side of a right-angled triangle. So when we move with vector 2, 40x, 40y, we are actually moving with a speed of 56x, 56y. But vector 2, 40x, 40y dot normalized will act more like vector 2, 28.28x, 28.28y. And that vector speed causes us to move with a speed of 40. So unless you really want your diagonal movement to be roughly 40% quicker than linear movement, just use the normalize function and the math is done for you. Delta is 1 second divided by the frame rate. The reason it is used is because if your game goes from 60 frames a second to 20 frames a second, it's going to slow down the game. If you don't want your game to slow down, you can multiply your movement with delta. Delta is going to equal 0.05 with 20 frames per second and 0.0167 at 60 frames per second. If you need to travel for 600 pixels at 6 pixels per frame, it is going to take 1.67 seconds at 60 FPS. At 20 FPS, this would take 5 seconds. But what if we were to travel at 360 pixels times delta frames per second? This would be 1.67 seconds at 60 FPS, and it would be 1.67 seconds at 20 FPS. The speed of movement would be recalculated per frame so that the game doesn't slow down. Move and slide automatically uses delta within its calculations, so it's not needed in this specific tutorial. But if you're creating your own movement system, you will probably want to use delta. A node is an object with various unique properties to it.
Okay, you're going through and explaining all of this stuff, going over speed and all of those variable mathematics, but then you backtrack to talk about what a node is. I feel like you're jumping around a bit randomly.
It can be
this
a child.
should have probably been first.
Using myself as an example, let's say that I am a character body 2D node. I have a couple of sprites of clothes that are connected to me and follow me around because they are my children and they are very attached to me. If I save myself as a scene, I'm now able to make multiple versions of myself, or I can place myself in new scenes. For example, I'm currently in my apartment, now I'm at the club. If I wanted to remove an item of clothing, I could just delete the sprite and it's gone. Perhaps I want to keep wearing a shirt, and if that's the case, maybe I'll just change the sprite. It's connected to me, so it's...
Okay, this is arguably the best version of an Explain Like I'm 5 that I've heard from this in a while.
Easy to change. That's pretty much the node system in a nutshell.
So he has all this stuff where he's talking about like mathematics, frame data, and everything like that. And he tries to break it down pretty well. And it's just like, this is what happens, this is what it does. But then he goes into something like this, and it's just a completely different style of an explanation. So this is something I would like to shout out in particular is the explanation of the
use
node
Delta.
system.
A node is
So we are going to copy this URL at the current time to add into our notes. Let's see. Day 2 tutorial explanations, so that we can link this in our description later.
is an object with various unique properties to its type. It can be a parent, it can be a child. Using myself as an example, let's say that I am a character body 2D node. I have a couple of sprites of clothes that are connected to me and follow me around because they are my children and they are very attached to me. If I save myself as a scene, I'm now able to make multiple versions of myself, or I can place myself in new scenes. For example, I'm currently in my apartment, now I'm at the club.
Okay. So we've got that. Let's move on to part 2.
Dawn Platinum removes 99% of...
Oh, the ads. All of them. Enemy AI. So this is something we haven't talked about at all.
In this episode, you will work out how an enemy runs towards you and tries to attack you. Hello, and welcome to How to Create a Vampire Survivors Clone in Godot 4, Part AI. And so this is really quite a simple and quick episode. So we're going to click on this plus sign to add a new scene, and we're going to be clicking on Other Node. Now, we are going to be adding a character body 2D.
Okay, let's pull up our thing again. What is this giving me for an error? This node has no shape, so it can't collide or interact with our objects. Not important right now. Okay. So we're going to add a new scene. Other 2D character body.
I'm just going to quickly rename this enemy. And in this
Oh, jeez. Okay. We've got our Godot.
enemy,
Yes.
we are going to be adding a sprite 2D. And
Not mine. Where's mine? Survive stuff. Add child. Bright 2D.
the enemy we're going to be adding is in our textures under enemy, and I'm going to be adding an enemy called Kobold Weak, which...
Okay, so we get to go back to paint. I shut paint off, didn't I? We want to make this one quite a bit smaller, though. Let's zoom in so we can still work semi-normally. We're going to make this enemy red, too. I guess we should probably do a little bit bigger circle for the head then. We'll fill this in. Yeah, we'll keep a little eye on him there, sure. We're gonna have little red man chasing us. Enemy 1. But then we're gonna go back to our remove.background. I wonder if that's gonna get rid of the eye. And yes, we want to replace it. Not there. So we have less windows to deal with.
Has the same issue as our player. It's got 2 frames of animation, and I'm going to go down into animation and click on H frames 2 to make sure that it knows that it has 2 frames of animation. And I'm just going to quickly...
We didn't do that with our other mobs. Okay.
Save our enemy. And I'm going to be creating a new folder called enemy to host our enemy in.
Create new folder. Enemy. We're going to put him in there. That's right. So let's go back to our 2D world. Unsaved. We can add our enemy up here. Close enough. Sure.
Now, we need to make our enemy move. I'm going to just quickly set the motion mode to floating, so it knows it doesn't need to deal with gravity.
I'm trying to skip as much as I can.
A script to our enemy. Well, for this, I'm going to just rename this to enemy underscore kobold underscore weak.
Well, we are going to go in here and first turn our music back on. And I need to rename mine. Enemy doggo.
And then I'm going to be adding our enemy to this. So I think I'm just going to create the script just called enemy generic. And then I'm just going to rename our enemy like that. So under
attach script. Enemy.
This, we're just going to once again remove all of this, and we're going to be creating a simple movement system. So
all the deletions. Yes, we'll get rid of the move inside, even though we'll probably use it later.
Unlike our player, we're going to be doing an export variable, and I'll show you what this does. Export var movement underscore speed equals 20.0. And what this does is now when we click on our our enemy, we have a new variable which we can edit within the editor. So I can just drag and drop, I can type in something else. I'm just going to leave this at 20 for now. And now...
Alright, so... variable... what was it? Movement speed. Cool, and it appears over here under our inspector node.
That we've done this, we are going to need a way for our enemy to detect the player. So I'm just going to quickly save that. And the way we're going to be doing this is with a concept called groups. So I'm going to go back to our player node, which I'm just going to click right there. It's up in there. If for whatever reason you've lost this, you can just go back into the player folder and try and find the, just type in player in here and click on the player.tscn and you'll find it. Now, we need the player to be in a specific group. So we're going to click on player, we're going to click on node, and then we're going to click on groups.
Okay, so we go down to our player. I just forgot what he said. Player, node, groups.
And we're just going to type in player and add. And this adds the player to the player group. And the player group is just a group that we made. I'm going to Control S to save. Go back to our enemy, click on the script, And now we need a way for our enemy to find the player. So we're going to make this an onReady variable, and what an onReady variable does is
onReady variable gets a value after the nodes are loaded.
I'm not entirely sure. It just makes something very easily accessible. So
great tutorial, buddy.
I'm just going to do an @onReady var player, and this is going to equal a function which is going to be called getTree. GetTree, just going to open my reference.
Ready variable player.
Script dot get first node. So the get tree is like, let's say it's like a level beyond world. So the tree would be the parent of the world. You don't see it here, but it would be the parent of the world, which goes, and what this does, it goes get tree, gets the first node in group, and we're going to set our group to player. So what this does is that our enemy script is going to go into the tree. It's going to say, hey, get me the first node you can find in the group player. And that's going to be our player, because our player is in the player group. And now we're just going to go into the physics function. So function physics.
Process delta.
We're not going to be using delta, so I'm just going to underscore it. That's how you determine and say that, hey, I don't want to use delta. And now...
But I had to use delta in my other one. Where is it? Player. It broke when I didn't. Never mind. I'm wrong. I'm wrong for some reason. More delta stuff causing me trouble. I have too many end quotes. Oh. Thank you, I hadn't caught that. I would have caught it here in a second.
We are going to create a variable.
Alright, so functions, physics, process, delta. I cannot type. Function. Am I just bad at typing something? Because it's the same thing I had here. Expected indent after. Whatever.
To get the direction that we want to move our enemy in. So var direction equals global position. Now the global.
Hey, whoa, hold on. There was an advertisement. All right, I'm tired of these short little videos I keep getting advertisements from. I need to go find another long soundtrack. We'll go back to this one.
Global position is the position of the enemy relevant to the tree. We're going to discuss this in theory time, and we're going to be doing the global position direction to, and we're going to be saying we want the enemy's global position and we want the direction to the player's global position. Dot global position. So it's a vector 2 to another vector 2.
So real quick, I'm going to move this up here so I can just copy this longer string. Variable direction equal global position dot direction to Player.global position. That's just got a typo in it, but global position direction to player.global position. That looks good.
2. We're going to be setting our velocity just like the player, and this is going to be equaling direction times movement speed. And then we're just going to be setting the move and slide function, which lets Godot know that we want this enemy to move. So now
we actually did that in our player one too. Oh, we did normalized movement slide. Was this indented though? No. Variable move equals, what is it?
When we play, and then we're just going to be setting the move and slide function, which
I'm making this more complicated than I needed to. All right. Velocity equal so variable directions. Velocity is direction time. Oh, because he has direction, not this. Direction times move speed, move and slide. Sometimes you just need to finish typing the body of the function for the IDE to clear. True. And I was not.
Lets Godot know that we want this enemy to move. So now, when we play, we'll see that, oh, I just forgot. We have to add our enemy into our world scene. So let's go back. We can see it's just our enemy now, but when we type in enemy, we can just go in there and we'll see that we have a kobold. I'm going to hold down the Alt key and click on the kobold, and I'm going to move the kobold.
That's what I was looking for earlier. That was so much better than trying to figure out all the stupid node grouping stuff. Okay. So we're going to go back to world. We're going to add our enemy. We need to add this one. Back to the 2D. Enemy doggo. Does that mean I... Oh, can I do player then over here? Yes, and I can put my player in the very beginning.
So now, I'm going to just save that, and I'm going to play our project. Going to walk down here, and we should see that a kobold is now chasing us.
Is that it? Haha! Eat shit, doggo! You can't touch me? I'm invincible! For probably like another 2 or 3 lessons. You are so slow. Alright, so if I want to change the enemy dog's speed, we can actually go back up here to our script editor, right? Then we change his speed to, let's say, 200. Redirect it. Yeah, and he is so much faster than us now. Cool. Save all scenes. Alright, where are we at on our Twitch stuff? Because we haven't run an ad in a while, so we probably... No. Okay, so the pre-roll. That's one thing I was happy about too. So I've tried to get the pre-rolls off, and now I don't have to manually run ads. It'll automatically run my ads every so often, which, as long as I start a stream by doing this manually, it'll then eliminate pre-rolls, because every time it gets to here, it'll reset that pre-roll ad. Cool. Perfect. Alright. All kinds of experimentation, we're learning stuff today.
And if we stop it is going to go inside us. Now, I want the kobold to be insertive rather than assertive. Well, I want it to be assertive rather than insertive. So we're going to be making a couple of adjustments. Number one, I forgot about doing this last episode, but we need to add a camera to our player. So I'm just going to add a camera 2D to the player.
So this is something new I haven't done.
This is just going to determine where the viewport is. We want to set this to current to let us know that this camera 2D is the current, and now the camera should actually focus on the center of the player and move with the player.
Camera 2D. Okay, we can do that. We're going to go to World, Player, add Camera 2D. So is there an edge of the map? Or do I have it set to loop constantly? I shouldn't be able to move down this far. So it must be like, oh, no. And I can go out of bounds. Alright, so we definitely still have things to work on. I really don't want it zoomed in that much. But let's try this as well, because we can go into our project settings. Window. So we override it for 1280. I don't want it to be that close, so let's change this to the 1280 by 720. Okay, so now we are definitely much smaller. Things are a bit more realistic for the size that we wanted. Perfect. Look at those textures popping in and out, though. That's pretty bad. Alright, look at the thickness of the lines, I mean. Wait, can y'all not see it? Oh well.
Now, to prevent our enemy from being insertive rather than assertive, we need to add collision shapes. So I'm going to go into our player node, and I'm going to be adding a collision shape 2D. And what this does, it allows for collisions to happen and makes it so that our kobold cannot go inside us. So the player will need a collision shape. So there's a variety of shapes you can choose from. You've got circles, rectangles. I've used a capsule. And I'm just going to hold down there and move it to sort of like the center of the player. I don't want it to cover everything. I want it to go a little bit inside, but that's all good. So that's the collision shape for the player. And I am...
So we've done this before. Let's see if I can remember how to do it, because he also just showed us how. So we go to the player. We attach a child. Collision shape 2D. So inspector, he doesn't have a shape. That's where we add the capsule. I wonder though, real quick, let's try something. Oh, that really messed up, huh? So let's do this. So that matches the player a bit better. Actually, I want to add a... No, not attached there. Attached to the player. We're going to add another capsule. But we want to transform it 90 degrees. And this way I can make... Oh. Why is it making me do both? I just want one. Maybe if we don't collide it. Transform, rotate 90. Boom, we've added an extra hitbox that covers just the arms. This way we can just be a bit more accurate.
I'm also going to be adding a collision shape to our kobold. I'm going to be adding that, just making this a bit small.
So this one we do actually need to flip. That looks good.
Holding down Alt and moving this towards here. Gonna Control S to save. And now when we run our project, we'll have our kobold not be able to go inside us as much. You know, give us some space. And that's actually it for the practical part of this tutorial.
I got them stuck on each other. I can't go right anymore.
So
Double
position
hitbox
and
was
global
terrible
position
idea.
are both vector 2 values. In the editor, you can work out what the position of an object is by going to the Transform tab. The position starting point vector 2 0x0y is on top of the parent of that.
Hey, I know, okay? I just thought I could be cool and fancy, and I was right. Let's just make sure it's not like something weird. Okay, yeah, like now I can actually get away from him. Oh, but I can still wear him as a hat. No, but it seems like some of the collision is just off. Because this is just one hitbox. So he's like stuck in my thing.
That node. If all of the parent and grandparents nodes have a position of vector 2 0x0y, the position value will be equal to the global position value. However, let's say we have a node 2D as a parent for our...
I completely missed what he was saying there.
If all we'll have our kobold not be able to go inside us as much, you know, give us some space. And that's actually it for the practical part of this tutorial.
Alright, theory time.
So, position and global position are both vector 2 values. In the editor, you can work out what the position of an object is by going to the Transform tab. The position starting point vector 2 0x0y is on top of the parent of that node. If all of the parent and grandparents nodes have a position of vector 2 0x0y, the position value will be equal to the global position value. However, let's say we have a node 2D as a parent for our enemies. If we move the node 2D node 100x pixels to the right, you will see that the kobolds shift to the right, but its position values remain the same. Now, the global position value of the kobold would be the kobold's position plus its parent's node 2D's positions plus any grandparents' positions. So, when moving objects and taking positions into account, if you only care about where the enemy is in comparison to its parent, then feel free to use position. If you need the enemy to consider a position to something that isn't its parent, in our case this would be the player, you will want to use and compare global positions. So in this episode we added our enemy AI and gave it a very basic script with a very basic command: move towards the player. So when the game starts, the enemy is going to go to the root of the scene and check for the very first instance of a node within the player group. Because the only node in this group is the player, the enemy will now know what the player is. So after that, after every physics frame, a calculation is done to compare the global position of the enemy to the player's global position. This is done with the direction2 function. The direction2 function will return another vector2 value, which will have a value of 1 to -1 x and 1 to -1 y value. If you were to plot this on a graph, this would be pointing towards a certain direction from the center. In our case, to the player. Keep in mind that the value is also normalized, so no need to add a normalized function to our direction. Refer to Theory Time in episode 1 for an explanation on normalization. After that, we multiply the direction vector 2 with the movement speed, and in our case, we will end up moving 20 times faster to the player. If we want to change the speed of our enemy, we can do so within our editor, rather than the script. If you want all enemy kobolds to have the same default speed, we can change the value within the enemy kobold weak scene. If we want the enemies to have a variety of speed, we can do so within our world editor and get a variety of speeds on our kobolds.
Okay. Please, by all means, join me, like and subscribe. That is probably one of the crummiest plugs I've seen in a while. Doesn't even say it, just puts it up on there, just like, please. Please do. Alright, so what is the next
I'm getting
one?
back on track with Factor. Fresh.
How? How did I do that? Why did that thing change my DPI? I hate this. I hate fucking G-Hub. Why did you change my DPI? Oh, come on. My normal DPI button's not doing it. I don't know where all my other buttons are, or why it suddenly does this. Oh, come on, mouse. I just fixed you yesterday. Why are you giving me this shit now? Oh. Thank you. Now I need to go in and adjust all this again. This is the one I had. This is what I like. But I want it to be a little bit slower. I want the 2350, and I want it to stay there. Okay, just don't touch it. Sit there. DPI up. Is that what I hit? I don't think I hit that button when I did it, but sure. Alright, whatever. Stupid mouse is stupid. Yeah, howdy Zen. So we've got 2 little game demos that we've got so far. We've got just generic Vampire Survivors. Trying to get that. We got it earlier, so he gets stuck on my head. I don't know why he gets stuck on my head, but he does. Because there's no hitbox associated with the legs on the art, so I don't know why those are getting stuck. Because these are the hitboxes. We'll just try moving that up, because why not? I can punch him, he's fine. I can kick him. No problems. Left punch. Good. Hat. We're fucked. I don't know why, but he doesn't like being... He just wants to be worn as a hat. And it is a completely circular collision box. Like, let's try putting it there. I now have a top hat. Let's go a little lower. So let's save all scenes. Then we've also got our other one that we did yesterday, which was a different project. Oh, hey, I can do it. Thanks for following. Appreciate it. Oh, no, not that one. I clicked the wrong thing. I got excited. I wanted to click on Dodge the Creeps. So this is the other one. This is the other tutorial we did yesterday that we actually completed. We're trying a bit more advanced one today. So in this one, we've got this. They give us all the assets and all the code, and it is loud. So, not sound settings. Volume mixer. Godot. Go right there. It's still the wrong one. There. Huzzah! We have animations, we have movement, we have sound. But we didn't make any of that. That's why I kind of wanted to do this other one that we've been working on. Where we're doing the survive stuff, because this is going to be all hand-drawn assets. MS Paint, and then when we need to, removing backgrounds and such. Ooh. Move the camera. And that's what we got. We got about a 4,000 square space that we're on. We're starting in this area. Camera's going to be our purple place. And we're in the process of making it work. Kick the box. Kick the box. And hat. I don't know why it functions as a hat, but... There's got to be some weird thing that we have in here with it. I don't know why. So that's a collision box here on the player. But it's going to be the character is going to be bound to die pretty quickly anyways. How are you, Zen?
Never frozen.
Oh, yes, advertisements. They don't need to be a part of our stream. Although that does look good, doesn't it?
In this tutorial, you will learn how to create some animations. Hello, and welcome to How to Make a Vampire Survivors Clone
12 minutes.
in Godot 4. So today we're just going to be working on some animations, and this should be very quick. So what we're going to be doing for our player is when it turns from, when we start walking left, we want it to be facing left. We also want it to be facing right. So we can edit this thing called PKayge, and based on where we move, it can move to that direction. So I'm just going to go back into our script. Just going to quickly get my reference up. And
your background is weird, dude.
All that's needed to be done here is to just say if mov.x is greater than 0, mov.x, which is the vector2 we already are using from our movement variable, is greater than 0. So this is the x coordinate of the vector2, so this is just that one.
Okay, so I'm going to go back to my scripts. Player.
We're going to do sprite. Oh, I just remembered. We haven't done already onReady vars, so we can reference our variables with various different methods. So we can do an onReady var on our sprite 2D. So, and this is done just by doing onReady var sprite, and then we just type in sprite 2D. And we can reference this. So there's a couple of additional ways to actually reference a sprite. You can also use access as unique name, which we'll do in a tiny bit. So from there, we can just do sprite dot flip h equals true. Elif mov dot x is less than 0. We'll do sprite dot flip h equal false. So pretty much based on our x value in our movement, if it's greater than 0, we'll flip h. Else we won't flip h, which is just the sprite 2D. So now when we run this, we should actually be able to, yeah, you can kind of see that we're swapping between them, which is all.
Oh, no, you can't have double equations in there. So with that, oh yes, haha, that's right. I did put a second animation here because it's not a perfectly centralized picture. We did do 2 animations for the player. Okay, so we're going back to here.
Pretty cool. Now, I also want to create the walking animation. So if we go in there, you'll see that we had 2 frames of our sprite, and when we increase the frame by 1, you can see that it moves a little bit. And what I want to turn this into a walking animation. So I'm just going to quickly add a new node called a timer. And a timer is effectively just a stopwatch. So we are able to set this as a one-shot, which means it only runs once. It doesn't continually run. And I'm going to set the wait time, which is just the cooldown of it, as 0.2 seconds. And I'm also just going to rename this as walk timer.
Okay, so we're adding a timer to the player. One shot, wait time 0.2.
I'm also going to be setting this as a access as unique name. And the reason we do this is because it can be...
Oh, I've been doing all this stuff in World, haven't I? Where does he have his set up? His is all, the camera, the collision is all under walk timer. Make sure that functions. Okay, it still works. Still have our hat. We're good. Our doggo hat. Collision shape is... What is his set? World 2D? Ew, no. Back up. Alright, there. We have cleaned it up.
Easier to reference. So walk timer equals get.
Oh, I missed a step, didn't I?
And I'm going to set the wait time, which is just the cooldown of it, as
I got distracted.
0.2 seconds. And I'm also just going to rename this as walk timer.
That's what it was. I missed renaming that to walk timer.
I'm also going to be setting this as a access as unique name. And the reason we do this is because it can be easier to reference. So walk timer equals get node walk timer. So there's
okay. Already variable walk timer. What is it? Get node. Well, why does he put... Oh, is that to... So why this?
There's many different ways to... Well, there's 3 different ways to reference your nodes. So you can do it with an onReady var. You can do it with a unique access path by doing this way. You just have to make sure that it has that percentage sign there.
That's why we have
And
it there.
then you can also do it by directly referencing it by just putting the $sign and doing camera 2D, and this will reference the camera 2D, but we're not gonna do that. So in order to get our walking animation, we're going to do if mov does not equal vector2 dot 0. That just means there is movement. If walk timer.
Okay, I don't know how to do that symbol. So we're gonna take a guess. Oh, where does he put it? Is it under move X? Is that right? No. How do you do it does not equal in Godot? Like that. I don't know how he wrote that. Alright, where's your video, dude?
They're equal vector2. We're going to do if mov does not equal vector2 dot 0.
So exclamation mark that.
That just means there is movement. If walk timer dot is stopped, so if it's not running, if the timer is not running, we're going to do a if sprite dot frame is greater or equal to sprite dot h frames minus 1. And we're doing -1 because on our sprite today, the frames start at 0, the H frames start at 1.
Alright, let me write this out, make sure I get this right. If mov dot, oh, not mov dot x. If mov is not equal to vector2 dot 0, and if walk timer dot is stopped, sprite dot frame, where is my greater than or equal to sprite dot h frames minus 1.
Sprite dot frame equals 0. Else sprite dot frame plus equals 1. So this is just going to loop. And then afterwards, we're going to make sure that the walk timer starts. So we do that just with dot start function. So now
that should be done there. Walk timer dot start.
Every single time we move, it's going to check the timer, and if the timer is not running, it's going to increase the frames by 1 until it's above the threshold, and then it resets back to 0. Because there's only 2 frames, it's pretty simple. So now when we move,
I'm getting a Lua error. Not Lua. Too much time on MUDs. Right, dot frame. There, that's what it is. So we should see our fat, ugly man walking now. Yeah! Boom! Stick figure galore. This looks so terrible, but yet it feels so fancy and special. I love it. Let's get a fancy man with a hat. Fancy man with a hat. Traveling, we traveling. Oh yeah. Now we're gonna go off screen because we must deliver the doggo. So we can force him up a little bit. But we're off screen now. And that's wonderful.
0. Because there's only 2 frames, it's pretty simple. So now when we move, we get this little walking animation, and we flip when we go left, we flip when we go right, all pretty simple. Now, we need to also do this for our kobold. I renamed this to kobold rather than kobold. So, this is all pretty simple as well. So we're just going to do the flip H very quickly as well. So if direction this time, because direction is dictating where the kobold goes, we're going to be, if direction X is greater than 0.1, sprite, once again, need to do an onReady var, sprite equals sprite 2D, sprite dot flip H equals true, if direction dot X is less than negative 0.1, sprite dot flip H equals false. So the reason we're having a gap between in 0.1 and,
so he also set the other onReady variable sprite equals sprite 2D.
negative 0.1 is just to stop incessant flipping. So now when we go to the right side of the kobold, it should flip. Yep, it flips. And now,
okay, cool, he flips. We didn't actually add a second animation for our fat dog though, so let's do that. Enemy. Copy. Add it about right here. And I want to take the eraser. We'll erase the legs. We'll just do a couple. Like that. So bring this back up. We're in 2D, yeah, because now it's showing this. So we go to our animation, we change this to 0, or change it to 2, so it drops it there to 1. Let's adjust this up a little.
it's going to be facing the direction it chases us. Now, instead of doing the way we animated our player sprite, you know, once again, it's the same basic concept. This has one frame of animation, very simple. We're going to be using...
Oh, can I check it right there? Where did he get that at? So he has the enemy kobold selected.
And one frame of animation.
And it's in animations under the sprite 2D. That's a little bit far left than I want. So let's actually go open up our paint again and readjust this. Like right there. Much better.
Very simple. We're going to be using an animation player. Now, the reason we're going to be doing this is because I want this to run all the time. So I'm going to create an animation player, and I'm going to create a new animation called walk.
Okay. So we tried to get this to work before, and we failed.
And I'm going to make this run all the time. So I'm going to create a
How did he get that screen at the bottom?
an animation player, and I'm going to create a new animation.
Oh, like that. I thought I didn't have it for some reason.
Called walk. And I'm going to make this animation play for 0.6 seconds, and I'm going to make this a repeating animation. So just as an animation loop. And we're going to be using keyframes to sort of say what we want each value to be. So I want the first frame to be frame 0. I'm going to create a reset track just so it knows what the standard is. I'm going to make in 0.3 frame 1, and then in 0.6 I'm going to reset back to 0. So now when we play this,
Okay, so see how he did it.
0. I'm going to create a reset track just so it knows what to be frame 0.
So he clicks on the key next to frame.
I'm going to create a reset track just so it knows what the standard is. I'm going to make in 0.3 frame.
So in 0.3, go to frame 1.
Frame 1, and then in 0.6 I'm going to reset back to 0. So now when we
I think I missed how he did that.
I'm going to make in 0.3 frame 1, and then
Wait, did he hit two things?
I'm going to make in 0.3 frame 1, and
Frame 1. Oh, and he pushed the keyframe thing.
then in 0.6 I'm going to reset back to 0. So now when we play this, we'll get a little bit of a walking animation.
Where's mine going back and forth?
All pretty simple. A little bit of a walking animation. All pretty simple.
All That doesn't quite feel right, but no, Grammarly, go away. Yeah, that doesn't quite feel right, but we're making progress. Ah. Hey, sorry. I guess my chat was a bit messed up. I can do it. Thank you for the follow. I didn't see your messages from earlier. Sorry for that, sir. I did not realize my Twitch chat was not updating. I'm not used to having to follow multiple chats at the same time. But thank you for coming in. I appreciate you. What do you mean you can do it? What do you mean you saw something you don't want to? Oh, well, best of luck on your exam, sir. Or madam, or whoever you are. Whoever you are, you can do it. I believe in you. I'm going to keep trying to go back to this, and it's the wrong one.
So to reference this,
see what we do.
I'm going to just do another onReady var. The reason I'm doing all these onReady vars is for management. I like being able to reference everything up here, and if I ever change the animation path and I reference it in multiple places, it may be good to just being able to change it once up here. Alternatively, of course, you can do it with the unique path of here, so you don't even have to change it unless you change the name.
So let's set that up. OnReady var anim, it's attached to the enemy. Anim animation player. Looks right.
So in order for this to play, we're going to be creating a function ready, which is a Godot function, and this ready function just runs once at the very beginning. So we're going to do anim.play, and then we are going to do walk.
That? Is that what you want? Anim play.walk, function ready. I'm guessing you want that after it?
Now,
no, you don't. Identifier. Oh, anime. Haha, yes, that's why. Because anime is not an action. Okay.
When we play, you can see that it is walking towards us, doing its animation. When we move, it works. So we always want the kobold to be doing the animation, so that's why I'm using the animation tree.
So it crashed. Attempt to call function play in base null instance on a null instance. So we missed something.
Just runs once.
Function ready.
At the very beginning. So we're going to do anim.play, and then we are going to do walk. Now, when we play, you can see that it is walking towards.
So we're in the enemy script, right? And on play, attempt to call function play in base instance null.
Everything up here, and if I ever change the animation path and I reference it in multiple places, it may be good to just...
Oh, huh. Is it because we did that? Yeah! So, well, it doesn't have to flip upside down. It doesn't matter. And we got our walking doggo hat. One of the most cursed images we've managed to make today.
Just being able to change it once up here. Alternatively, of course, you can do it with the unique path up here, so you don't even have to change it unless you change the name.
Gee, things are telling me the thing I just figured out.
In order for this to play,
I should have just watched the video.
We're going to be creating a function ready, which is a Godot function, and this ready function just runs once at the very beginning. We are going to do walk. Now, when we play, you can see that it is walking towards us, doing its animation. When we move, it works. So we always want the kobold to be doing the animation, so that's why I'm using the animation tree, and I'm using code to animate the player. To make games in Godot, it is very important to reference nodes and manipulate their values. This is commonly done through onReady variables. You have 4 different ways of referencing a node. Number 1, directly reference it with the $sign at the start and then type in the name with the path of the node. Number 2, use an onReady variable to and then reference the path of the node. Number 3, onReady variable with access as unique name and using the getNode function. Number 4, using a diverse function to fetch a node. All of these have advantages and disadvantages. Direct reference is the easiest to type, but if you ever change the name or path, you will have to change it in multiple areas. onReady variables with a reference to the node path takes a bit more time to type, but if you change the name or path, you will only need to change it in one area. onReady variables with access as unique names let you change the path freely, but the node needs to have a unique name in order to reference it. If you change the name of that variable, you will also have to change it in the onReady variable. Using a function to fetch the node is powerful if you don't know the exact path of the node, but it's also going to require the most amount of effort to set up. Chances are that you will use all of these methodologies at some point, and while some are better than others in certain situations, they all basically achieve the same thing. Use what you're most comfortable with at the task at hand.
Okay, so your theory on this one was completely wasted on anything you did this time. All you discussed were the onReady variables. So I didn't really like that. But it's about that time that we're going to go ahead and call it. We've been studying for approximately 4 hours today, and yeah. So, thank you all for tuning in. I'm going to go dig around, try and find us someone that we can watch. See if we can get anything in software and game dev. Let's see if there's anyone that can try and teach us stuff. We actually visited Nova Liminal yesterday. You're learning Rust. Skill stack. Is there anyone doing Godot specifically? This guy. I don't know that I saw this guy. I think I came in right as he was finishing his stuff yesterday, and he was piecing out.
Bold of you to assume you're getting in. Wait, what?
Yeah, let's go say hi.
Okay, so we have this part. Now, what North Pole was saying is
just
go here.
Covino.
We're gonna.
So I'll see you guys in a bit. We'll check him out.
Var.
Just say hi, and
Scroll container.
I will catch y'all tomorrow.
We don't even need this.
And we'll take a break for the weekend after that. Thank you all for coming and hanging out. Y'all have a good one.
And then